Here's another example of a two-variable statistics or linear regression problem. So here we have some data, and we want to linearize it. As we've mentioned in previous videos, the first step is to make sure that both data sets are on the increase, and that is not the case here. The force is increasing, but the distance is decreasing, and that isn't going to work. So what we want to do is we want to take the decreasing data set and take the reciprocal of all of those points, including the variables. The variable for force is usually capital F, variable for distance is going to be D. So the new data column is going to have the variable 1 over D, because we're taking the reciprocal of everything, and the unit will be 1 over meters. Then into our calculator, we go 1 over 3.57, etc. for all of those. And as I determined, here are what those come out to. 0.280, 0.395, 0.485, 0.559, 0.625, 0.685, and 0.741. Once we've done that, I like to put a line through that data because it's no longer going to be a value in terms of what we need to type into our calculator. So both columns are on the increase. Looks good. Now we check for linearity. Mentally, we say, all right, if the force doubles from 1 to 2 newtons, what happens to this column? 0.28 to 0.4 roughly? Wow, that's not even close to doubling, because if this doubled, wouldn't it be about 0.56? Let's check one more. From 2 to 4, what happens here? 0.395, which is about 0.4, to 0.56, that is not a doubling. Somebody is having trouble keeping up, and that would be this column here. And whoever's having trouble keeping up, we now need to square that column. So we're going to make another data column, and this one's going to be 1 over d squared, and the unit is going to be 1 over meters squared. And if we type these in, squaring everything, this is what I get: 0.0784, 0.156, 0.235, 0.312, 0.391, 0.469, and 0.549. And once we've modified this column, any column we modify, we cross that off. All right, let's check for linearity again. 1 to 2 over here, roughly 0.08 to 0.16. Ah, that's a doubling. Looks good. Let's check here. 2 to 4, 0.156, doubled. Yep, looks good. So those two columns are what we want to put into our calculator. The question now is, which ones should be the x values and which ones the y? We look at the units and we go rise over run. Newtons divided by 1 over meters squared, or 1 over meters squared divided by newtons. There's not really a best answer for this one, perhaps, but it's simpler, isn't it, if we take newtons and divide by 1 over meters squared. In other words, rise over run, because then the slope would have the unit of Newton meters squared, instead of a slope being 1 over Newton meters squared. So I think the best policy here would be to make these the rise values and these the run values. So let's put that into our calculator, which I've already done because I'm trying to save you and me some time while making this video. We go into the stat mode. We're going to hit edit, enter. And you can see I've put the x values in column L1, the y values in column L2. Let's quit. Not clear, quit. We go back into the stat mode, and now we want to calculate. We want to do a linear regression. So we toggle down to that, hit enter. I've already arranged things the way I want them. I'm just going to hit enter a few times, and here we have our answer. Let me sneak this over just a bit. What my calculator says is that y is going to equal 12.8x plus 0.0063. Now, don't leave your answer in terms of x and y. Typically, you want to use the variables that we have here. So instead of y, we're going to put capital F. And instead of x, what's x? X is 1 over d squared. So you could write it 1 over d squared if you want, or if you want to just put the d squared in the denominator, you could do that. Plus 0.0063. And quite often, the intercept will be a very, very small number, and so it's often acceptable. You do what your teacher tells you, obviously, or what the problem says. In this case, it seems to be reasonable that we could completely neglect that intercept and just report it something like that.